Hello everyone, welcome to this special episode of Keys to AWS Optimization. In today's video, we're going to be giving you our reInvent talk, Advanced Analytics with the AWS Cost and Use Report, for those who weren't able to make it there live, or those who watched us live and want to just rewatch to learn a little bit about what we did. And we're just going to go straight into it. And we've got Justin, who's my co-speaker for this, who also did an awesome episode of Keys a few weeks ago, so go and check that out. Without further ado, let's get into this session. Today, you're all likely spending money on AWS, but understanding the nuances of this data can be tricky. This talk will equip you with the knowledge and techniques to harness the full potential of your AWS cost and usage report, or the CUR. We're going to write some queries, we're going to analyze some data, and we're also going to connect some other data sets. My name, as you probably know, is Steph Gooch. I'm a Senior Optimization Architect Advocate. Justin?
I'm Justin Marks. I'm a Senior Technical Account Manager.
Perfect. So this is going to be a code talk at reInvent. So we're actually doing live querying, and we're going to do that for you. And we're going to be doing SQL queries in Athena. If you like, you can follow us while watching this video, or you can always watch back later. Or at the end, we'll be sharing a QR code, which has all of the queries that we show today. So if you want to write those to yourself, then you can have a go and share them for your organization. But I wanted to talk about this, the AWS Cost and Use Report. Now, this is in the title of this session, and it's going to be our main source of data. If you don't know, this is a huge set of data which contains all of your usage and spend across all of your accounts. And we often shorten this to the CUR. But we didn't actually want to have this in the title. We wanted to have data exports. But we weren't sure if people would actually know what this was. Now, if you're on this channel, you probably have heard me talk about it, but this is the new home for the Cost and Use Report and some other data sets. It is important to call this out so that you know where you can find any of these data sets that we mention as we move forward. So what is inside this so-called data sets? Well, we have four things. Firstly, we have the AWS Cost and Use Report, hundreds of columns wide, millions of lines long, and you probably know this data set well. But there's a little leg in that icon, and that is because we have CUR 2.0. As the name suggests, a brand new version of this. And this has some exciting new announcements that Justin's going to go through in a minute. Next, we have Focus, our open source specification that normalizes your cost and usage data. And this is for people who have multiple cloud vendors they're working with. The idea is it reduces complexity when you work with cloud spend. So if you're a multi-cloud person, this will be really important for you. And Justin's going to do a small snippet on this to show how it compares in terms of querying with the other data sets. Finally, we have Cost Optimization Hub. This is a really awesome tool that helps you identify, filter, and aggregate over 15 types of cost recommendations. This is free and you have to enable it, so make sure you go and do that. Today, we're not going to be diving into this. We'll be focusing on the data sets, but it does live in data exports where you can export the data into S3 and query it as you wish. Question for the audience, though. Have you deployed CUR 2.0? You can drop it in the comments. If you have not, the whole year I've been pushing this as a concept, so make sure you go and do this. I'll drop some links below to make sure you know how to do this as we move forward. But let me hand over to Justin, who's going to take you through some different updates and things that you can take advantage of when it comes to the new CUR.
So before we get to writing Athena queries, let's cover some of the changes between CUR 2.0 and legacy CUR, starting with schema consistency. So in legacy CUR, you know what it looks like. We have columns, and really there's no way to fit all of them on one slide. And the ellipses in the middle here, that could be potentially 500 or more columns. I've seen legacy CUR reports myself with over 500 columns. And you've probably had this situation happen to you. You're an engineer. You're asked by your manager, your boss, to start helping allocate costs by tags. And maybe you want to hone in on your environments, right? You want to start allocating your cost data by prod and dev. So the next day, you come in, you enable your tag for cost allocation because you already have it out there. Your team's already using it. And the next day, you check your CUR data, and what do you know? Those environment tags are in there. Job well done. You pat yourself on the back and say, we're done here. And you let your manager or boss know everything's well, right? Then somebody from a BI or a data engineering team gives you a call and wants to know why you broke their pipeline. and why they're getting alerted for it. And why did you do this? And why did you change the schema? To bring this back, though, there's a lot of things that you can do. You can see some of the mentions in the top there, like buying your first savings plan or enabling additional cost allocation tags that can change the legacy CUR schema. So how do we handle this in CUR 2.0? So when you create a CUR 2.0 report, you have options. You have your SQL statement if you're building it from the console, or you have the query statement parameter in the API, where you can write a SQL query to lock that schema. So you won't have that problem we talked about in the previous slide. As an example, this query here would lock our CUR 2.0 report to these 3 columns, and it wouldn't change. It would be consistent, and your teams can expect the same format forever. And then you can see the note, the third column here too. You can use this query to get your CUR 2.0 reports to be legacy CUR compatible, and you can adopt CUR 2. So you can adopt CUR 2.0 and not have to worry about that compatibility. All right, let's talk about some additional columns in CUR 2.0. In legacy CUR, you would probably be paying attention to account ID pretty often, both for the payer and for the usage accounts. And it's likely that if you work with CUR data regularly, you've started committing some of these numbers to memory. You'll know that that account ending in 9012, that's your production account, and the one in 9013, that's your dev account. But sometimes when you're digging into anomalous usage, or you're digging into an alert, and you find that you need to go look into usage for a different account, you might not have that committed to memory. You have to go look it up, or you have to do some joins with other maps that you've been maintaining. But with CUR 2.0, there are 2 new account name columns that were added, both for the payer and for the usage account. So you don't have to keep this separate account map, do these joins out of band, and we'll use some of these columns in the queries that we'll show you today. Let's talk about nested data. So this is a new construct for CUR 2.0. In legacy CUR format, remember when we enabled that environment tag for cost allocation, so let's say a few days later, you enable the app tag too. And every time you add a new tag for cost allocation, you're going to get an additional column in this 500 in the middle. So with CUR 2.0, resource tags collapse into a nested column with key value pairs in a JSON map. And this is true for cost categories, for some of the product columns, and some of the discount columns. But the result here is going from 500 or more columns total to 125 columns total, assuming you have all features enabled. This will reduce your data sparsity, so you'll have less null values across your CUR 2.0 reports compared to legacy CUR. And finally, when querying these nested columns in CUR 2.0, there are 2 ways to filter them in your where statement. So if you wanted to hone in just on your tagged production costs using that environment tag that we set up earlier, you can either use the element at function to pull the environment tag out of that map, or you can use square brackets and reference the tag key to do the same. And this query here would show us all the line items for app 1 and app 2 in production. And that covers most of the changes in CUR 2.0. So to kind of rephrase Steph's earlier question at a different angle, hands up or drop it in the chat. Who, after going through this, plans on deploying CUR 2.0? So I hope everyone has their hand up. We're going to be keeping an eye on adoption.
100%. We want to encourage everybody to go move to 2.0. But let's get querying. We know that's what you want to see in this session. But warning, even though we're doing this on a recording, I am dyslexic. There might be errors. We in reInvent are going to tally them up. Today, we're hopefully just going to get through with not many errors, but at least you'll be able to see how we construct the queries and also how we figure out errors if they come up, meaning that you might learn a little bit more. But what queries are we actually going through today? We're going to do 4 different ones. So firstly, Justin is going to take us through the different data sets we mentioned. So legacy CUR, CUR 2.0, and focus, and explain how to convert between them. Then he's also going to show you your top 50 movers in spend, so you can see if anything's changing in your accounts dramatically. I'm going to take over, and we're going to be looking at redistributing your savings plan savings in a report. And then finally, we're going to connect some other data sets and start to look at some optimization. We pulled these ideas from common challenges we see customers face, so we hope that you can utilize them in your organization. But with that, over to you, Justin, to start some demoing.
All right. So let's just hop straight into Athena. The first thing we're going to cover is how the Kerr data looks in different data export report formats. So let's start with a really simple kind of refresher warm-up query, and then we'll just kind of convert it between the three. So starting with legacy Kerr, what are your most expensive resources and how much did they cost? So you can see from our query here, we're going to hone in on account ID, product name, the sum of the cost for that month. We're selecting it from legacy Kerr here, and we want to hone in on August. We're going to do the needed group buys, and we want to order by cost descending. This will give us our most expensive services in August. And if we check the results here, we should see EC2, S3, RDS. And this is expected. They're all happening in my prod account because I've memorized 9186 as the production account. And just to take quick notes on some of the costs here, 1674, 534, 256. Okay, we should get these to match. So if we wanted to convert this to Kerr 2.0, let's go ahead and copy and paste this. And let's see what happens when we change to the Kerr 2 table. And you know what? I didn't select my query. So let's start by doing that. All right. Column not found. Month cannot be resolved. Okay, so it looks like in Kerr, we don't have the same projected partitioned columns at the end here that we've used in legacy Kerr. So we used to use year and month here. So let's see what we have in Kerr 2. And let's take a look at the data too, just to make sure we understand what we're working with. Okay, so if we do a preview of the Kerr 2 table, and let's scroll all the way to the end, we don't have year month anymore. We have this billing period column. So we're going to need to change that. And you can see it's 4-digit year dash 2-digit month. All right. So let's go back to our basic template here. And we're going to need to change this to billing period. And I'm just going to use the full string here. If you wanted to hone in on month and year, you could parse those out, but we're not going to do that today. Okay, and we were working on August. So what else? We know we talked about the new name fields for accounts. So let's change this from account ID to account name. Let's make sure we update it in both places. And let's see what happens with product. This is one of the categories of data that got folded into that JSON map, collapsed into that JSON map. So product name can't be resolved. So let's see what we have out here. So you can see we have this product column now, and it has that JSON map in it. And I would suspect that's where my product name is. We could take a quick glance here at our preview, and we'll hop just far enough over to see this product JSON map. So you can see inside of here, we have product name as one of the keys. And you can see what the values we're looking for as the value there. So to get that, we're going to need to change this to either square brackets or that or the other function that I was mentioning before. But we're going to stick with square brackets, and we're going to add some aliases here too. So we're going to call this product name. This is still cost, and we'll change it here as well. And this should give us our Kerr 2.0 results. There we go. And you can see 1674, 534, 256, same values. We have the account name now. So now we can track these linked accounts versus org accounts, etc. Cool. All right. So let's hop over to Focus then. Now, Focus converting to focus is going to be a little bit different of an approach because the schema is different. So we know we want account name. Actually, let's just copy and paste this again. All right, we're going to need to change our data set to focus here. And let's take a quick preview of what's going on in our focus report. All right, so we can see, we can pull things like account name out of there. That's good. This is the billing one. There should be one for sub-account name. If we scroll all the way to the end here, lucky for us, billing period is going to stay the same between cur 2.0 and focus. So we'll stick with that. And service name looks like it's what we're going to hone in on for the product name. So let's make sure we change these to sub-account name. We're going to change this to service name. And then we're going to keep cost, but they don't have a blended cost. We're going to use build cost. That's going to be what's going to get us the closest to unblended. Focus, billing period stays the same. We'll copy and paste these down here, and we should have a working focus query. All right. And same as always, costs are aligned. They're the same as the other two. We have our sub-account name. We have our service name. Great. All right. Hopefully everyone's warmed up. So let's hop over to our top 50 spending resources. So you're going to need to write a query that shows you what your top 50 most expensive resources are and how their costs have changed day over day. And our plan is to do this in cur 2.0. So let's hop over to our top 50. So we're going to do this in cur 2.0, and we're going to start with usage from 3 days ago. And then our plan is to compare it to usage from 2 days ago. So let's start by selecting cur 2. So we're going to want this from cur 2. And we're going to grab the resource ID. We're going to grab the account name. Oh, not the bill payer account name. Let's grab the usage account name. We're going to grab the product name again. I'm just going to borrow it from my query over here. Let's grab the usage date. Usage start date, and because our cur report is an hourly granularity, we need to aggregate this to the day, right? So for 24 hours. So we're going to use date format to do that. And so we're going to feed it that column, and then we're going to use a filter here to tell it we want a 4-digit year, a 2-digit month, and a 2-digit day. And we're just going to call this as dates. All right, and then we need to throw cost in there. So we need unblended cost. And you know what, I think I can probably borrow this from this query as well. So we're going to grab our unblended cost. We're going to round it to sum it all up, and then we're going to round it to 2 decimal places because no one likes to pay in fractions of a penny. All right, cur 2, and then we want to make sure in our filters that we pull out blank resource IDs. An item resource ID. And that's because if we don't do that, there's a chance that we have this really big amount of spend for something like data transfer or something that doesn't have an associated resource ID. So that wouldn't be helpful. And then let's go ahead and we don't want to write a static filter for 3 days ago, right? We could type in 11/23 if today's the 26th. But then we'd have to go and update every time. So we want a rolling window. So let's go ahead and let's do this with start date. So what we're going to do here is we're going to and line item usage start date. And we're going to create that rolling window by using current date, which should give us today's date. And we're going to use the interval function to give it a value of 3-day. And this should say we want to see usage where the start date was today minus 3 days. Let's add all of our, you know what, I'm just going to do 1, 2, 3, 4. I wouldn't put this in production, but we're going for speed today. All right, and that should give us our usage for 3 days ago. Let's go ahead and highlight this and run it and make sure that it works. All right, so we can see which instances and load balancers in which accounts 3 days ago. This looks right, and their costs. Great. All right, so now that we have one working query, let's scroll down, and we need to get another data set here. So we need to get usage from 2 days ago to compare it to, and we only need to change one single character to do this. So what is it? And hopefully, if you found it before I changed it here, you can let us know in the comments. We're going to change the interval from 3 days to 2 days. So this should give us all the data, all the usage data for our usage from 2 days ago. And we can check it just to make sure. Let's check our results here. So we have our instances, our IDs for different resources, and the 24th. So this looks right to me. All right, so now we need to do some math to figure out those changes day over day. Before we do that, we're going to wrap our two queries up here in a with statement. So this is going to let us work and join this data without having to like nest it inside of froms and some other stuff. So we're going to do this one is 3 days as we're going to wrap it in parentheses. We're going to do another one here. This one's called 2 days as we'll wrap it in parentheses. All right, and now we should be able to start doing the math to figure out our changes. Okay, so let's select everything from 2 days ago. We're going to do 2 days, dot star. Let's select everything from 3 days ago as well, dot star. And let's figure out how much that cost has changed. So let's grab our 2 days cost, and we're going to subtract that from our 3 days cost to figure out how much it's changed from 2 to 3 days ago. And I like to wrap all this in parentheses. We're going to call this as cost delta. All right. And cost delta is great, but let's also figure out what the percent change is, right? So if it went from $1 to $2, we'd want to see 100% in here. What we're going to do is we're going to wrap this in another set of parentheses, and we're going to divide this amount by 3 days cost, which will give us a decimal of the percent, but we're going to multiply that by 100 because we don't want to have to do that math in our head. All right, so that should give us our as percent delta. Cool. All right, we're going to grab this from cur2, and this is where we're going to do some of this join. Okay, so we're going to grab it from cur2, or you know what? We're not grabbing it from cur2. We already have those data sets from our results above. So we're going to do from 3 days, and we're going to do a full outer join on 2 days. So why a full outer join? Well, we want to see resources both that existed 2 days and 3 days ago, and we want to see resources that existed only 2 days ago because it's a new resource, or only 3 days ago because it got deleted. And we're going to join these 2 data sets on the resource IDs, right? We want to see those overlaps. So let's grab line item resource ID, and then let's make that equal 2 days ago. All right, combine rows for resource ID matches. Cool. Let's make sure we order by cost descending, and let's also see percent descending in case they match. And then we're going to limit 50 to see our top 50. All right, fingers crossed. Oh, 45. Where did I mess up my query? Percent delta. All right, if anyone sees it, feel free to yell it out. Although I know you're watching a recording. Let's see, where did I mismatched input open? Close those, close those. Let's see, did I mess up? I didn't mess these up, I don't think. These look okay. Steph, you don't happen to see where I messed up, do you?
No, I'm trying to look in. This is live querying, folks. December. That's
From
fine. It's 43. That's the line. All right, we'll swipe ahead to when we fixed it.
Aha, okay. And here we are. So now we can see our usage from a couple of days ago on the 24th, how much it cost, how much that same resource cost 3 days ago, the cost delta. So you can see that this resource went up 9 cents in guard duty, and that went from 0 to 9. So that's notable. And that's it. That's all I have for now. Hopefully we'll have some better examples for the demo at reInvent.
Yeah, but it's good because it shows, again, this is a demo account, but at scale, you'll probably be seeing different instances or different resources, or maybe something you weren't anticipating. All right, back over to me. We'll see Justin in a sec. So what I wanted to do for my section was about redistributing commitments. So as you probably know, savings plans are applied to the account they are purchased in and then allocated based on where you can make the most savings in your organization. However, we hear from customers they want to control where they can allocate these savings. Now, you can't actually do that, nor would you want to, because you want to get the biggest savings, but you do want to be able to calculate this, and this is what we're going to be doing today. So we're going to look at how to find how much saving we made from a commitment, and then we are going to look at our tagged resources and redistribute the savings based on their consumption of the whole bill. So we're rewarding those that tagged their resources, and then we could use that for chargeback in our report. So let's go on over to our account. So I've already started with a base query, and in this we have a sum around a case statement. So a case statement is like an if statement in queries. So when line item type equals savings plan coverage usage, aka when a savings plan was applied, then saving plan effective cost. So this is, imagine you were meant to have a resource that cost $10, you had a savings plan applied which saved you 40%, it now costs you $6. That is your effective cost. Then we're going to minus line item unblended cost, our original $10, and that's going to be our number. So L0 we don't care about because savings plan wasn't affected. And if we look, this is our saving, 277 for the month of September. Now, if we go into my account, we can see month of September, there's my savings. So yes, I've made this query correct. But what we want to do is, now we've worked that out, is we need to work out what our tagged resources spend were and proportion distribute those out. So let's start to pull some information in. So we're going to bring in resource tags. I'm going to spell this wrong. So this is going to be a user tag. So user underscore FinOps is the one I have. And we're just going to call this user FinOps to be easier. I'm also going to pull in month and year because we'll be using that in a bit to distribute our cost. So I can steal this from this extraction of the billing period here. And because those are kind of single values and not calculations, I'm going to add them to a group by 1, 2, 3 at the bottom. So now we have that information. What else do we need? Well, we need some normal spend, some unblended spend. So I'm just going to sum my unblended cost. This is going to be my item. Oh, there we go. And for this one, I'm just going to call it sum to show I've calculated it. Brilliant. Now, what else do we need? Well, I mentioned we're going to reward those that have been tagged. So we're going to use another case statement for this. So surrounding inside a sum case when my resource has been tagged, aka when resource tag user is not null, then I'm going to get the unblended cost, else 0, we don't care. And this is going to be as tagged spend. Come on there. My question is now going to be, did I spell? I don't want to get an error, so I want to focus on my resource tags. I'm just going to check I spelled it correctly and grab that here just in case. Yeah, it looks like it was okay. Okay, brilliant. So we've got my commas. Let's give that a run. Oh no, I did error. Oh, every time, not. And here we'll start to see the base of our data for today. So we have our tags, the month and year they were used in, so September, and their unblended cost, as well as their tagged cost. So this is really evident when we have our untagged resources here. They cost $148 last month, but they have 0 tagged spend, which is correct. But they saved $7.57. Now that's not good. We want to redistribute this saving to be a bit more fair. For example, this T3 workload, they definitely have tagged resources in. There's things like EC2s in there, but they didn't get any savings. So let's take this spend and use a with statement to group it all together. And then we can refer to these in these calculations. Now, we're going to use, first of all, an over function to sum our savings. That way we can use it in our calculation. So we do this, we're going to do a sum. And we're going to grab our sum savings over partition by month, year as total savings. Now, these are often easier to show rather than tell. So what will happen is, remember that 277 we had earlier? Now I have a whole column with that information in. So again, when I can distribute these savings, I can use that in my calculations in the rows. So we'll do the same thing, but this time we will use our tagged spend. So I'm going to grab this, drop it in here as total tagged. So we know that these resources cost this much and their tagged amount was this much. So what we need to do is we need to say, what is this divided by our total tagged, and then times it by our total saving, and then add on our original spend to work out how much to charge them. We'll do that in 2 sections. So the first one is taking our total tagged and dividing it by our total spend, which should be nice and easy because we've already got these things. So we are going to take our tagged spend. So for that, we're going to use another case statement to check it's valid. So case when, where's my resource tag? So when a tag is not null, then sum unblended cost divided by we can put, actually, we can summarize that in there, else 0 end divided by our total tagged as percent. So we drag that along. Okay, so we can start to see some of these calculations. Let me close this so we can see all of it. So for example, our untagged 0, that's correct, but our T3 workload is about 16%, which is correct. So now we just need to times it by our saving. And again, the good thing is we've already got this calculation. So we can take this whole thing, drop it there, just times it by our total saving, that 277. And because this is the chargeback report we're doing, I'm going to add on our sum unblended cost, our original cost. In reality, you could smush all of this down, but we want to see all these steps. So now we have how much we can charge. So for example, let's go to our empty workload, not tagged, not changed, perfect. But our T3 workload was 235, but now it is 281. So it's made a saving, which is good. So hopefully from that you have learned a little bit about what the savings plan columns are. We've talked about over functions to get that same one across each row, and also max, and also some case statements, because it's good to know how to do these if statements in code in queries. On to the very last query, which is actually going to be pulling in some other data sets. Now, there are many different things you might want to pull in when it comes to your cur to enrich it, things like business metrics, utilization metrics. But in this one, we're going to actually be bringing in configuration information about resources. And we're going to be focusing on AMIs and snapshots. So in the picture above, we can see how we utilize snapshots with AMIs. We have an AWS volume, we take a snapshot, we use it to make an AMI, and then we spin up lots of lovely EC2 instances from that. But the question is, what happens when you delete this AMI? Then you no longer need the snapshot because it's not connected to anything. We're not using it for anything, but you have to delete it. And I see so many customers forget to delete it and they end up paying for it. Now, snapshots are incremental, they're not small, they're very small cost. But when you have this at scale, or if you have something like a golden image process and you are constantly spinning up EC2s, trying out how to install stuff on them, and then creating AMIs, but not actually using them and getting rid of the AMIs, you have all these full snapshots with all of the kind of imprint of everything that's in it that you're paying the full amount. Now, we need to find out this connective tissue between our snapshots and AMIs, and this is not natively in the cur. So what we've done, we've built something called the optimization data collector. What this will do is it will pull in your cost and usage data, your resource information, like we mentioned, those AMIs and snapshots. It will also bring in things like price lists if you need it for certain queries, and also give you queries like the one we're going to go through so that you can start to analyze this data. Now, we're going to show a QR code at the end on how you get this deployment, this solution, but you do have to deploy it in CloudFormation into your account. We've already done that today. So we're going to go through how we extract information from each of these data sets and how we connect it back to the cost and usage report. So let's get into it. So for this one, we're going to be using a different database. So instead of data exports, we're going to be using optimization data. And let's have a look at our tables. So if we preview this, so let's get a view of what this data entails. We have things like image ID, who the owner is, what platform they're on, all relevant information. We'll come back to the AMI. We're going to start off with the snapshot one. Now this has a similar kind of information, but wait, what do we see? AMIs. So in the description of this information, we can see this connective tissue, and this is what we're going to utilize to bring this all together. But before we do, we need to make sure we have the newest set of data. So this optimization data collector, it actually runs on a 2-week frequency. So you can see this data is September. We've definitely got newer data in here. So what we need to do is we need to use a max function to get the newest date in this set. However, because this is actually just a string, we also need to convert this into a date. So the way we do this is we max, and then we date pass that collection date column. And the format, we saw it below, is going to be, let's pull this up, is year, month, date. Year, dash month, dash date, and then space, we have the time as well. And we'll call that as snap date. And there we can see the 25th of the 11th. So that's our newest data set. Perfect. But we need to pull out some other information. So we're going to be using a with statement to get this in there. So with snap. Oh, can't spell. Snap. This as bracket. Now, what do we actually need from this inventory? We had a look at the start, but we're going to need that description for sure, maybe an owner ID and a snapshot ID and that collection date. So for that, we need to do an inner join. And I'm going to bring Justin back up to explain what an inner join is.
So if you do joins in in SQL. Most languages interpret that as an inner join. If you don't have to specify inner join typically, but if I don't know, see if this will work. So
yes, a little bit.
it's this Venn diagram right here where you have two tables, and what we're looking for the results is just overlaps in those two data sets. So in this case, Steph's writing a query that's going to just show us data from that snapshot data table where it has that maximum snap date.
Perfect. All right. Justin, do you want to stay here? Or do you want me to take you back down again?
I can hang out.
You can hang out. Okay, perfect. So we've now got that information and we've got our latest snapshot data. Perfect. So we also need to start extracting this AMI information. And I want to save a bit of time for this. So what we're going to do is we're going to take this from a query that already exists. So we're going to use one of those case statements that we did in the last query. And rather than have description, we're going to have this. Let's format this a little bit. So from that description, when the substring that starts with created by image, split it up on the space and get the 5 characters. So what this does is it pulls out this AMI and does it for other types. Else we don't care about it. It will be blank. So if we run this, we should now see instead our AMIs, which is super helpful. Okay, so that's all we need for extracting our snapshot data. So we'll call this snap bracket and drop these in a subset of data. Now, we also need to get our cost data. And again, by saving time, what we're actually going to do is use our Cur query library. Justin, do you want to explain what this is too?
Sure. Yeah. So the cost and usage report library is part of well-architected labs, and it's a place that you can go to get started with Cur queries or just go derive some inspiration. We have queries out there in legacy Cur format and Cur 2.0 format. We have 1 or 2 queries in focus format today. So you can see we already have a query published out there for EBS snapshot costs. So this will save us some time by borrowing some of the work that we've already put out there.
Yeah, so if we run that, we should just see our spend for the snapshots that we have. Yay, perfect. So we can drop this into another subset of data, cost as right, that is all the snapshot information we need. We can now go back to our AMIs. So the things we need from this is very similar to the start. We need to get the max information, this max data. So I'm actually going to copy this query and drop it in here. So we already know that works. And what other information do we actually need from select? Oh, the from. What other information do we need from our AMI table? Well, in reality, we don't really need that much. We only need the image ID and the connection to our data, our substring of data, so we can copy that in a join. I won't get Justin to re-say again what that was. We can drop this in here and start to just flip these around. Da, da, da. And grab this. So hopefully this will just show you my list of AMIs that are existing in my organization at the moment. And as you can already see, there's a very short list compared to the snapshots. So this is going to be interesting to see which ones exist compared to which ones were created by the AMIs in the first place. So let's take this on over to our big query. Make sure we add a comma in there. And we have AMI latest. And we can also do one last one, which is AMI. Oh, don't forget the as. Brilliant. So we're going to select everything first. So select snapshot. Double check I called it snapshot. Like Justin, I always change it to snap. When you're doing it live, I feel like I change the name of things. Snapshot.star and then ami.star from snap. And we need to make a join. So this time we're going to do a left join. Justin, do you want to explain that for me?
Yeah, so back to my little graph that I'll hold in front of my camera. There we go, left join. So we're going to be joining two tables together. The left table being...
Oh, pause for 1 second.
Go
I'm going to
ahead.
start again. I've got delivery. Bear with me. Hello, please drop it outside. Oh, it's at the front door. Hang on. I think someone just locked out the building. All right, let's kick off again. I don't know where I get to, but it's Christmas deliveries. Okay, so where did I get to? I feel like I might just leave that in and be like, pause. Okay. And we're back. Justin, let's do inner joins.
Yeah,
I mean, left joins.
A left join, yeah. So a left join in this case, you can see from my camera table here, we're going to be joining two sets of data. And the first one that Steph specifies here, snap, we want everything from snap. And then we also want to see overlaps from AMI. So if they're where she's joining on image ID and AMI ID, we want to see that AMI data pulled into the result set here. You need a comma, I think, right? Or no. 6-1 all the way at the top.
Oh, 6-6. Oh wow. Oh no. Oh, snap as.
There we go.
No, 40. Dot. That's the right way around, isn't it?
Left join AMI on.
Oh, on.
There we go.
We're like even on errors. That's So yeah, like Justin was saying, we now have these images that connect to these image names and some that don't. We can see a bit of a gap here. So what we're going to do is we're going to do one more case statement, and this is to make it a little bit more obvious of which ones are there and which ones aren't. So for this, we're going to do case when and use the logic from our join. And when that's true, then AMI available. And the next one is when my snapshot AMI ID like AMI $, then AMI removed. This is going to work because anything that matches the first rule will be flagged as AMI available, and then the second one will be taken into consideration. So the ordering is really important here. Else, not AMI, got to keep it as the same string and as status. So now it should be a little bit more obvious when we have these gaps. Okay, AMI available. AMI removed. There probably are some other ones. AMI removed. So I can delete these snapshots. Now, in some cases, I've seen this list very, very long. It just depends. So the last thing we're going to do is add in our cost data. So we want to make sure we have all of our spend. So we're going to add in cost dot, and I have to find my cost, our sum unblended cost. And then we're also going to have a join on this one. So we're also going to left join cost on snap dot to go right up to the top and grab our snapshot ID this time. So a little bit different, equals cost dot, and go back up and grab our resource ID. And now we should also see our spend in here. And there we go. So got a whole 0.4 cents being spent on that snapshot. Ooh. But as we said, we want to make sure things at scale are improved. And through this, we want to make sure that you learn how you can actually take advantage of connecting lots of data sets and finding those tangible bits of information and the different joins that Justin went through of how you can connect these for different end results. Okay, that is it for querying. So on to the last part, which is our call to action. Number 1, move to Code 2.0 if you haven't already. I'm going to drop a link to a blog below that will show you how to do it and all the advantages based on some of what Justin said. Partner the data sources. This is a little bit harder, but also if you have things like utilization metrics or business metrics or want to use the inventory collector, you can enhance your data so much more and learn what's going on. And finally, if you are newer to the Curve, just have a go. Check out the Curve query library and get started on querying and see what is going on in your data. We've got a link tree here filled with all the useful links, plus the connection to the GitHub repo we mentioned to make sure that you can have these queries to hand so you can mess around with them. So take a look at that. And finally, you're all on here. But if you haven't, then make sure that you have subscribed to this channel. And thank you so much. Thank you so much, Justin, for joining me.